The Great Attractor, the invisible force pulling galaxies together. Space is not as still as it seems. Though the night sky looks frozen in time, every star, galaxy, and cluster is moving, drifting through the cosmos at incredible speeds. Our own Milky Way is racing through space at over 2 million kilometers per hour. But here's the mystery. Where exactly are we going? And what is pulling us there? Astronomers discovered that all galaxies in our region of the universe, including the Milky Way, seem to be moving toward a mysterious gravitational anomaly located about 150 to 250 million light-years away. This strange region, hidden behind the dense band of the Milky Way, is known as the Great Attractor. It is one of the most puzzling phenomena in modern cosmology, an invisible gravitational force tugging on entire clusters of galaxies, yet no one can see what it is. The discovery of a cosmic mystery. The story of the Great Attractor begins in the 1970s and 1980s, when astronomers began measuring the motion of galaxies using redshift data. Redshift occurs when light from distant objects stretches as they move away from us, a direct result of the universe expanding. However, something odd appeared in the data. Galaxies in our local region, including the Virgo cluster, Hydra-Centaurus supercluster, and even our Milky Way, were not moving as the Hubble expansion predicted. Instead of drifting away evenly in all directions, they showed a peculiar motion toward a specific part of the sky in the direction of the constellation Centaurus. It was as if something massive, unimaginably massive, was pulling them in. At first, scientists thought it was an error in observation or data interpretation. But as more telescopes and instruments confirmed the same pattern, the evidence became undeniable. Something truly enormous was exerting a gravitational pull across hundreds of millions of light-years. Hidden behind the Milky Way, one of the biggest challenges in studying the Great Attractor is its location. It lies in what astronomers call the zone of avoidance, a part of the sky heavily obscured by the dust, stars, and gas of our Milky Way's galactic plane. Optical telescopes cannot easily see through this dense cosmic fog. For decades, this made the Great Attractor almost impossible to observe directly. Scientists could only infer its presence from how galaxies around it moved. But as new instruments became available, particularly those that could detect X-rays and infrared light, astronomers began to peer through the dust. What they found made the mystery even deeper. A supercluster hidden in plain sight. In the 1990s, X-ray observations revealed a massive structure known as the Norma Cluster, Able 3627, located near the suspected center of the Great Attractor region. This cluster is incredibly dense, containing thousands of galaxies bound together by gravity. It sits roughly 220 million light-years away and is considered one of the most massive nearby clusters. This discovery helped explain part of the gravitational tug, but not all of it. The Norma cluster alone wasn't massive enough to account for the immense pull affecting such a large region of the universe. That meant the Great Attractor was just one part of something even bigger, perhaps a supercluster of superclusters. Further research pointed to a more extensive structure called Laniakea, meaning immense heaven in Hawaiian. In 2014, scientists mapped out this enormous region, revealing that the Milky Way, along with over 100,000 other galaxies, is part of the Laniakea supercluster, spanning more than 500 million light-years across. The Great Attractor sits near the heart of this supercluster, the gravitational center around which everything in our cosmic neighborhood flows. So, in a sense, the Great Attractor isn't just pulling galaxies. It's shaping the entire architecture of our corner of the universe. The nature of the invisible force. But what exactly is the Great Attractor? There are several possibilities. 1. A massive concentration of matter. The most accepted theory is that it's a region filled with an enormous amount of visible and dark matter. The combined gravitational pull of galaxy clusters, dark matter halos, and superclusters could explain the motion of galaxies toward it. 2. A gravitational anomaly beyond the observable universe. Some scientists suggest that the Great Attractor might not be the final destination at all. Instead, our galaxies might be pulled toward an even larger structure beyond our visible horizon, known as the Shapley supercluster, an uneven, more massive concentration of galaxies located behind the Great Attractor. 3. Dark matter and dark energy interplay. Another intriguing idea is that the Great Attractor's gravitational signature might be influenced by the mysterious forces of dark matter and dark energy, which together make up about 95% of the universe's mass energy content. Perhaps what we perceive as a pull is actually the result of complex interactions in the cosmic fabric itself. Why it matters. Understanding the Great Attractor isn't just about curiosity. It's about uncovering how the universe is structured on the grandest scales. The motion of galaxies tells us about the distribution of mass, the shape of space-time, and the hidden influence of dark matter. The Great Attractor also challenges our perception of the universe as uniform and evenly expanding. It reminds us that, while the cosmos is vast, it's not random. It's interconnected by colossal gravitational webs stretching across unimaginable distances. Even our solar system's motion, the movement of everything we know, is influenced by this invisible cosmic current. In a sense, we are all drifting toward the Great Attractor, carried along by forces we can barely comprehend. The ultimate mystery. Despite decades of study, the Great Attractor remains an enigma. We cannot see it directly, we cannot measure it precisely, and we cannot yet explain its full nature. It is both a real gravitational center and a symbol of cosmic humility. Every galaxy, every star, and even the Earth itself is moving toward this mysterious destination, pulled by a silent cosmic hand. Whether it is a vast cluster of galaxies, a dark matter concentration, or simply a glimpse of something beyond the edge of the observable universe, the Great Attractor continues to whisper one of the greatest unsolved questions of cosmology. What lies beyond the cosmic horizon? Until we can peer deeper through the fog of the Milky Way, or develop technology to map the hidden parts of our universe, the Great Attractor will remain one of the most fascinating mysteries in all of space. In the end, the Great Attractor reminds us that the universe is alive with motion, bound together by invisible threads of gravity. We are not standing still. We are passengers on a galactic river, flowing toward an unknown destiny. Somewhere in the darkness, beyond the curtain of stars, lies a force so immense that it bends the paths of galaxies, a silent titan that shapes the cosmos itself. It is the Great Attractor, the invisible force pulling us ever closer into the heart of the universe's greatest mystery.